All right, here we're on chapter 8, and then we're in section 8.4 now on other functions and their properties. Now, our objectives are introducing nonlinear functions, expressing domain and range in interval notation, recognizing absolute value functions and their properties, recognizing polynomial functions and their properties, recognizing rational functions and their properties, and then performing operations on functions. Now, some of these we've done before, but we're going to just hit on them again a little bit. So expressing range and domain in interval notation. So the set of all valid inputs for a function is called the domain. So remember, inputs, those are usually our x values, and the set of all outputs is our y values. Because remember, it's f of x equals, some 2x plus 4 or something like that. So we're inputting x and we're getting out y because y is equal to f of x. And so that's why inputs and outputs. Now, rather than writing the set of all real numbers when you can use any real numbers for the domain of f, we can use interval notation. And this is what I've shown you in the past. Instead of using all real numbers, I just showed you from negative infinity to infinity. And so that's kind of an easier way than writing out the set of real numbers. I also, if you remember, I wrote R for the real numbers. Okay, so those are three different ways we can show the set of real numbers. All right, so what we're supposed to do is write the domain for each function in interval notation. And I believe this this is something like we had almost exactly before. And so here, no matter what number we put in here for x, we can get out a y value. And so this is going to be the set of all real numbers. Now, when we plug this one in, we can't have 0 in the denominator. So what we do is we set this equal to 0 and solve for x. And so when x is equal to 4, that's equal to 0. So here x cannot equal 4. And so there was, a couple ways we denoted that one. And we could say that, or we could say from negative infinity to 4, union 4 to infinity. Or we could say, it says all real numbers except for x equals 4. And so there's a bunch of different ways. So again, this one was all real numbers like I showed you. And this one we're using this notation now. So it's, all the numbers except for 4 is written in this manner. So we're trying to get more into this interval notation now. All right, we've looked at absolute value functions before as well. And so to graph it, basically we're going to make a table. And so the best way to do that is, go on each side of 0. So in this case, they went 1 on each side of 0, or 2 on each side of 0, positive and negative, as well as the 0. Okay. And when you do that, you get out a set of y values. And so then you can plot it, and if you're doing it by hand, it's not going to be nice and straight. But if you can use your Pearson or you can use your calculator, you're going to get some nice straight lines and stuff like that. So that's what it's going to look like. Okay. Now, I guess the key thing here is if it asks for the domain and the range, we can write that. So the domain is going to be what? Well, it's going to be all real numbers because it's just going to keep going up and up that way and that way. And so it's going to be from negative infinity to infinity. And our range, well, we start at 0, and so it's going to be bracket 0 all the way to positive infinity. What about if we want to sketch a graph of f of x equals x minus 3, then write its domain and range in interval notation? Well, again, plotting points. So basically, we're going to make this table of values. And in this case, it really doesn't matter. Maybe we just do 0, 2, 3, 4, 6. Okay. So we're going to plug those in, and then we get our y values out. Now, we could have gone 0, -2, -3, -4, -6, and we could have got something. But we could also plug it when we plug in this. Where is this at 0? Well, it's at 0 at 3, and so that's be our kind of our point where it's been moved. Because remember over here, 0 is at 0, but when we have the -3, now all of a sudden it's over here at 0 is going to be right here. So it's just shifting our absolute value to a different place. Okay. And what we've done is we've shifted it right. So when we have x minus 3, we've shifted our function 3 spaces to the right, and it looks basically the same as it did before, except now we're just shifted one way or the other. In this case, we shifted to the right because we subtracted 3. All right, so now what's our domain and what's our range? Well, our domain is going to be the same thing from negative infinity to infinity, and our range is going to be the same from 0 to positive infinity. So That's what we have here. So the domain and our range. All right, so let's stop here and we'll come back for some more.